Hello, everyone, and welcome back to Tea Time with Meg. I'm so happy to be back, and I'm so happy you're here with me. So grab your favorite cup of tea, coffee, or whatever you're drinking today. Get comfortable, and let's talk about something that is quite literally out of this world. Today, we're heading into space, and we're talking about NASA's newest space telescope, the Nancy Grace Roman Space Telescope. Now, if you've never heard of Roman before, don't worry. You don't need to be an astronomer, you don't need a degree in astrophysics, and you definitely don't need to understand complicated math. Because today, we're going to talk about what Roman is, why NASA is sending it into space, and what it's going to look for, and why scientists are so excited about what it might discover. And honestly, I'm pretty excited too. Because every time humanity builds a new space telescope or new telescope in general and points it towards the universe, we seem to discover that the universe is even stranger, bigger, and more fascinating than we thought. And Roman might be about to do exactly that. So grab your tea and let's go to space. Let's start with the basics. The Nancy Grace Roman Space Telescope is a NASA space telescope designed to study some of the biggest questions we have about our universe. It's named after Nancy Grace Roman, a pioneering astronomer who became NASA's first chief astronomer and played a major role in making the Hubble Space Telescope possible. She's often called the mother of Hubble, and I think it's really fitting that NASA named the next generation telescope after her. Roman is going to be looking at the universe primarily in infrared light, and it's going to be doing something incredibly important, which is surveying enormous areas of the sky. That's really the key to understanding Roman. Hubble is famous for taking incredibly detailed pictures. James Webb is giving us an amazing look at the distant universe, particularly in infrared. Roman is going to help us look at huge portions of the universe all at once. How cool is that? Think of it this way. Imagine you're looking through a telescope and seeing one beautiful section of the night sky. Now imagine zooming way out and being able to survey an enormous neighborhood of the universe while still getting incredibly detailed information. That's where Roman comes in. Now you might be thinking, wait a minute, Meg, we already have Hubble. And yes, we do. And then we have the James Webb Space Telescope. So why do we need another one? Well, because these telescopes aren't really competing with each other. They're more like a team. Hubble has been observing the universe for decades. It's incredible for detailed observations and has helped us revolutionize our understanding of space. Then came Webb. Webb is designed to observe primarily in infrared wavelengths and has allowed us to see extremely distant galaxies and objects from the early universe. And then there's Roman. Roman is designed to survey enormous areas of sky. Its primary mirror is about 7.9 feet, or about 2.4 meters, across roughly the same diameter as Hubble's. But Roman's wide field instrument can capture an area of the sky at least 100 times larger than Hubble's field of view. Think about that. Same general mirror size, but a dramatically wider view. So rather than asking which telescope is better, it's more about asking which camera lens you want to use. Sometimes you want an incredibly detailed close-up. Sometimes you want a wide-angle photograph. And sometimes you want both. Let's talk about one of the coolest parts of Roman. Its wide field instrument. Basically, Roman has a giant scientific camera. And when I say giant, I mean it can capture an enormous amount of information. The wide field instrument contains a detector with roughly 300 megapixels. Think about that for a second and let that sink in. That's a lot of pixels. And it's designed to observe infrared light. You're probably asking yourself, well, why infrared? because infrared can reveal things that visible light can't show us as easily. It can help astronomers see through some dust and gas and observe very distant objects whose light has been stretched toward infrared wavelengths as the universe expands. So Roman isn't just going to take pretty pictures, it's going to collect an enormous amount of scientific data. And that data can help us answer some very big questions. Now, we get to the really exciting part, which I'm really excited for. Why are we sending this telescope into space in the first place? Well, there are several giant mysteries, and I'm talking some of the biggest questions in all of astronomy. Dark energy. Let's talk about dark energy. And yes, the name sounds like something straight out of a science fiction movie, but it is what it is. But dark energy is one of the biggest mysteries in modern cosmology. We know that the universe is expanding, but something strange is happening. The expansion of the universe is accelerating. Scientists call whatever is causing that accelerated expansion dark energy. But here's the frustrating part. We don't actually know what dark energy is. We know what it appears to do, but we don't know what it actually is. Roman will survey huge areas of the universe and study galaxies and other cosmic objects to help scientists better understand this mysterious phenomenon. And maybe, Roman will help us finally figure out what is going on. Now, the next cool part is dark matter. So then we have dark matter, another wonderfully mysterious name. Unlike ordinary matter, dark matter doesn't interact with light in the way normal matter does. So we can't simply look at it through a telescope, but we can see its gravitational effects. It's kind of like seeing footprints without seeing the person who made them. We know something is there because of what it does. Roman will help astronomers map the distribution of matter throughout the universe and study how gravity affects the shape and positions of distant galaxies. And that could give us a much better understanding of dark matter. Now, let's move from the biggest things in the universe to something a little closer to home. Planets. Specifically, planets orbiting other stars. These are called exoplanets. We've already discovered thousands of them, and Roman could discover many more. One of the really interesting techniques Roman will use is called gravitational microlensing. That's a lot of words, and even I am still confused about it. Don't worry, we'll learn. We're going to get there. We're not going to turn this into a physics lecture because I don't know physics. Here's the basic idea. Imagine you have a star in the background. A different star passes in front of it. From our point of view, the gravity of the closer star bends and magnifies the light from the star behind it. And if the closer star has a planet, that planet can create a tiny additional signal in the light. Roman can detect that signal. It's almost like the universe is creating its own cosmic magnifying glass. How cool is that? And this technique could allow Roman to find planets that are difficult to detect using other methods, including planets that are very far from their stars. Wow. Okay, now, here's the question I think a lot of people are going to ask. Could Roman find another Earth? The short answer is maybe. Think about that. Maybe it could find another Earth. But there's an important distinction. Finding an Earth-sized or Earth-like planet is not the same thing as finding life. Those are two very different questions. And I'm not going to get into the whole alien finding life situation because that's just a topic for another day. Roman will help us discover and study populations of planets beyond our solar system. Its surveys could tell us more about how common different kinds of planetary systems are, and that's incredibly important because every new planet we discover helps us understand how planets form, how solar systems develop, and how unusual or ordinary our solar system might be. But the possibility of discovering something completely unexpected, that's what really excites me. So, where does a telescope like this actually go? Roman will travel about 930,000 miles, or roughly 1.5 million kilometers from Earth. It will operate near something called the Sun-Earth Lagrange point. I apologize if I mispronounced that, but again, I'm only human, we know this. Or, for short, and easier to pronounce, L2. Now that sounds complicated, but basically it's a very special location in space where the gravitational relationship between the Sun and Earth allows spacecraft to maintain a useful position relative to the Earth and the Sun. It's the same general region of space where the James Webb Space Telescope operates. So Roman is going to be incredibly far away, but still part of our neighborhood, our very, very large neighborhood. This is probably my favorite question. What could Roman discover? Because we know that Roman is designed to study, but we don't know everything it's going to find. And that's one of the most exciting things about science. We can build an experiment around a question, and the universe can answer with something completely different. Roman could help us understand dark energy. It could give us better maps of dark matter. It could discover thousands of new worlds. It could help us understand how galaxies formed and evolve. It could find black holes. It could reveal strange planetary systems. It could uncover objects we've never seen before. And maybe it could discover something that completely changes what we think we know about the universe. That's happened before. Hubble gave us discoveries that changed astronomy. Webb has already challenged some of our ideas about the early universe, and Roman will have its own story to tell when the time comes. We just don't know what that story is yet. I think it's worth coming back to the person behind the name. Nancy Grace Roman wasn't just a name chosen for a telescope. She was a scientist who helped shape NASA's astronomical program. She advocated for space-based astronomy and played an important role in making this Hubble Space Telescope possible. And now, decades later, a telescope carrying her name is preparing to continue that legacy. There's something really beautiful about that. One generation helps build the tools, and the next generation uses those tools to see even farther. And I love that it's a female. And I'm not going to get into, male versus female, but I am very excited to know that a woman, Nancy Grace, has shaped science in a way that could change everything. So, why should we care? Why should we care about another space telescope? I think the answer is pretty simple. Because we're curious. Humans have been looking at the stars for thousands of years. I do it, you do it, even if it's a quick glance or an hour-long session or longer. We've always wanted to know what's out there. Are we alone? How did the universe begin? How did galaxies form? How did the planets form? What is dark matter? What is dark energy? What else is out there that we haven't discovered yet? And Roman is another tool that helps us ask those questions. It reminds us that there is still so much that we don't know, and honestly, I think that's exciting. The part that I'm most excited about. If I had to choose one thing I'm most excited about, it's not necessarily the specific discoveries scientists already expect. It's the possibility of the unexpected. I'll let that sink in for a second. Imagine scientists looking at Roman's data and suddenly saying, wait a minute, because of that moment when something doesn't fit the model can completely change science. Maybe Roman will find a planet we didn't expect. Maybe it will reveal something strange about dark energy. Maybe it will uncover a new type of cosmic object. Or maybe it will answer a question we've been asking for decades. We don't know. And that, my friends, is the fun part. All right. Tea break. Let's take a little tea break, and I have a question for you. And I want to hear your thoughts and your questions. If you could ask the Nancy Grace Roman Space Telescope to answer one question about the universe, what would you ask? Would you want to know if there's life somewhere else? Would you want to know what dark matter actually is? Because I do. What would you want to know? Would you want to know what happened during the earliest moments of the universe? Or would you ask something completely different? Personally, mine would be, what is the universe hiding that we haven't even thought to look for yet? Or how common are potentially habitable worlds in our galaxy? Because imagine getting an answer to that question. That would change everything. All right. In closing, I think one of the most amazing things about astronomy is that it gives us perspective. Our everyday lives can feel enormous. Our problems can feel enormous. Our worries can feel enormous. And then you look up at the night sky and you realize just how unbelievably huge the universe is. There are billions of galaxies, billions of stars, countless planets, and we're standing on one tiny world. Granted, Earth isn't that tiny. We know this. But you get my point. Trying to understand it all, and now we're building machines that can look farther and further than previous generations ever could. The Nancy Grace Roman Space Telescope is another step in that journey. We don't know exactly what it's going to discover. We don't know which theories it might confirm. We don't know which ones it might challenge. And we definitely don't know what surprises are waiting for us. But soon, Roman will be looking, and I can't wait to see what it finds. Make sure to tune in to the launch of the Nancy Grace Roman Space Telescope on August 30th, 2026. So in just a matter of a couple weeks. It sounds like it'll be launched around no earlier than 8 in the morning. So make sure you tune in. That's a Sunday, folks. Make sure you watch, because I will be. As always, thank you so much for joining me for another episode of Tea Time with Meg. I hope this was an informative episode, and I hope you enjoyed our little trip into space today. And maybe the next time you look up at the stars, you'll think about all the things we haven't discovered yet. Because somewhere out there is still so much waiting to be found. Until next time, keep the kettle warm and your heart cozy.